Good morning, madam. Myself, Dev Budensa. I am from CSA section at Srinivasa Ramaya Institute of Technology. Today, I will discuss explain adjacent matrix and incidence matrix with example. Introduction to adjacent matrix. An adjacent matrix is a square matrix used to represent a infinite graph. It indicates whether pairs of vertices are adjacent or not with binary values. Each row and column corresponded to vertices in the graph with entries showing connections. Properties of applications of adjacent matrix. The adjacent matrix provides a straightforward way to analyze graph, connectivity, and structure. Especially used for dense graph where many vertices are interconnected. Applications include network analysis, shortest path algorithm, and graph traversal technique. Introduction of graph matrices. Graph matrices are tools to represent relationships between nodes in a graph. They simplify the analysis and computation of graph properties. The main two types are adjacent matrix and incidence matrices. What is an adjacent matrix? An adjacent matrix is a square matrix that shows which nodes are connected. Which nodes are connected represent nodes and entries indicate edges between them. It is mainly used for representing simple, unweighted, and undirected graph. Structure of adjacent matrix. The size of the size of the matrix is x into n, where n is the number of nodes in the graph. If there an edge between nodes I and j, the entry at I, j is 1. Otherwise, it is 0. For undirected graphs, the adjacent matrix is symmetric along the diagonal. Graph representation of undirected graph to adjacent matrix. Example of an adjacent matrix graph. Consider a graph with four nodes A, B, C, D. Edges are between A to B, A to C, B to D, and C to B. What is an incidence matrix? An incidence matrix represents relationships between nodes and edges. It is a rectangular matrix with rows as nodes and columns as edges. Entries indicate whether a node is incident to an edge with specific values for undirected graph. Structure of incidence matrix. For undirected graph, entries are usually one if the node is part of the edge, or otherwise. For directed graphs, entire can be -1, 0 or 1 to show directionally. The number of rows equals the number of nodes and the number of columns equals the number of edges. Example of an we about discussed previous slide adjacent matrix discussed. Today example of incidence matrix graph. Using the previous graph with four nodes and four edges, assign edges. E1 is equal to A to B, E2 is equal to A to C, E3 is equal to B to D, E4 is equal to C to D. Comparing adjacent and incident matrices. The adjacent matrices focuses on node-to-node relationships, while the incidence matrix employs node-to-node relationships. Adjacent matrices are square, but incidence matrices are rectangular. Choice depends on whether the analysis requires understanding the connectivity or edges node relations. Adjacent matrices are square, but incidence matrices are regular. Square depends on whether the analysis requires understanding node connectivity or edge node relationships. Applications of these matrices. Both Matrices are used in network analysis, computer science, and social network studies. They help in algorithms like shortest path network flow and connectivity analysis. Efficient storage and computation can be achieved using these matrices in large graphs. 3 plus 4 is equal to 7. 3, 4, 7. Conclusion and summary. Adjacent matrices provide a directed way to visualize to node to node connection. Incident matrix show how nodes are related to edges, useful for different types of analysis. Understanding both matrices engages the ability to analyze complex networks efficiently. So, thank you. Thank you, ma'am.